Hello, my name is George C. Bradley, and today's presentation will be on how to run a one-sample t-test in SPSS. Quick overview, we're going to define a one-sample t-test. We're going to look at the assumptions underlying one-sample t-test. We're going to look at a research question and hypothesis, and then we're going to look at a short demonstration on how we analyze a one-sample t-test using SPSS. The goal of this presentation is to run a one-sample t-test using SPSS, and after the presentation, our participants should be able to define a one-sample t-test, run an example of a one-sample t-test in SPSS. We should be able to interpret the data from a one-sample t-test. Our definition: a one-sample t-test is used to test whether the sample is significantly different from a population mean or some type of hypothetical value. Assumptions underlining the one sample t-test. You have two assumptions here. Assumption one: the test variable is normally distributed in the population, and you have two parts of assumption two. You have the random sample, whether it's a random sample from the population, and that is no, and then you have the scores on the variables are independent of each other, and that's correct. And you can see if you violate the second part of that, what will happen. We have that in bold. Let's test the assumption one. As we can go to our data set here, we have a GPA of the student athletes. And if we go to Analyze Descriptive Statistics, Explore, you can see here we have GPA, student athletes. We will click that over to Dependent List. Nothing really with the statistics, but the descriptive information. Your plot here, you want to make sure that you use the histogram. We can take the stem and leaf out. Normality plot with tests, we want to use that. Continue. Nothing with the options. I don't want to use anything here with the bootstrap, but we want to make sure under display we want to use both. We want to use the statistics and the plots. Okay, as you can see here, we have descriptive information. If we go down to the descriptive information, two things here that can tell us whether this is normal distributive, that our particular sample population here in the means, the sample population. We can see under skewness, if this number is between -1 and +1, it's normal. One kurtosis, -2 between -2 and 2, it's normal. So with the descriptive information, it passed the normal test. So we can go right here and test the normality and the significance here. Both of the significance are above 0.05. If it was less than 0.05, we would reject it, but we accept the null here, and it's above 0.05, so it's not significant, and that means it's normal. We can look at our histogram, and it's not a perfect normal curve, but it has some of the shape, and we can look at our QQ plot, where very few of them are off, most of them are very close to this line here. And our bottom plot right here, the GPA student athletes, you can see we have no outliers. So let's go back to the presentation. And as we look at our next point here, writing the research question, let's look at an example there. Is there a difference in the student athlete's GPA as compared to the GPA of a non-student athlete at a small university? That's a question. And that's a question that's asked at a lot of small and large universities. You can see our hypothesis here. We have a null and we have an alternate. The alternate is there is a difference in student athletes' GPA as compared to the GPAs of non-student athletes at a small university. In the null, there is no difference in student athletes' GPA as compared to the GPAs of the non-student athletes in a small university. So you have your null. You have your alternate, and then you have your null hypothesis there. Let's look at a quick demonstration. Let's look at what we should do here. We should open and identify the database, examine the one variable, click on this information, select the button with compared means, go to one sample t-test, highlight and click GPA student athletes to the test variables and type in your t-value. We'll talk about that t-value, and let's look at an example of this. Okay, you can see the GPA of the student athletes. We can go here, we have compare means, we can go down, one sample t-test. That's our variable there, that's our data. We want to click that over to the test variable. It's only one variable here. And we can go right here, our test value. This information, this is the non-student athletes. That's the population at the small, this non-student athletes at the small university. And the information that I received from institutional research, which would have all that information, the GPA of the non-student athletes is 2.5. 2.5, and as we go here to option, there's nothing here that we have on the options. So let's analyze this information. As we can see, the GPA for student athletes, the number, I mean, you have 20 and it's small, and the mean GPA is 2.445. Standard deviation is 0.54. And as you can see, this number right here, this is the sample mean here. The information below, the t-value is negative. It's negative because it's less than 2.5. And the significant value, it tells us whether we accept or reject the null hypothesis, is 0.655, and that's above 0.05. So that means we accept the null. And as we can see, there's no significant difference between, no significant or meaningful difference between 2.5, the population, and the sample 2.44, which the difference is a negative 0.05, which is there's no difference there. As you can see again, the population mean, that t-value, it's not significant from the sample mean, and the difference here is extremely small. If you have any questions, please shoot me an email. My email is georgecbradley59@gmail.com, and I can answer any of your questions pertaining to the one sample t-test. Thank you.